Special relativity is a field of physics that explains how space and time are connected for aligned objects traveling at steady speeds v relative to speed of light c, where 1, all laws of physics are the same in all reference frames, and 2, all reference frames measure the same speed c. Let's look at an example of special relativity so you can better understand what special relativity is. The example that we're going to look at is how space is connected for aligned objects traveling at steady speeds v relative to the speed of light c. Let's take a look at the example of length contraction. We have an equation for length contraction, that is L is equal to L naught times the square root of 1 minus v squared divided by c squared, where L naught is length measured in a stationary frame, and L is length of an object in a moving frame at speed v greater than 0.5 c as measured by an observer in the stationary frame. Well, let's take a look at this example. So here we have an observer. The observer is looking at a rocket that's sitting there in the Earth or stationary frame. So this person's on Earth. They see a rocket. The rocket is just sitting there at speed v equal to 0. It's not moving. And they're going to measure the length of this rocket, and they measure a length L naught. Then they look out in space in a line, so the objects are all aligned. So they're looking out in space now, and they see a rocket that's moving at speed 0.995 c, and they want to measure the length of this rocket that they see moving at this speed as measured from their stationary frame. So this is the moving frame, and they're sitting in the stationary frame, and they measure in the sky the length of this object, and we'll call it length L. The true length is L naught. The length that they measure in the sky is length L because the object is moving at 0.995 c. So they're going to observe this original length L0 to be contracted to a smaller length of L, and that new length L that they're looking at the object in the sky is equal to the original length L naught multiplied by the square root of 1 minus v squared divided by c squared, where v is the speed of the object moving in the moving frame. So the speed is 0.995 c. You plug this into this equation relative to the speed of light c and solve, and you can find out what the new length is based on the original length. So now let's go back to the definition of special relativity. It's a field of physics that explains how space and time are connected. In this case, we're looking at length, and we're not looking at time. There's other examples of special relativity that look at time. Specifically, we're looking at length, and we want to see how length is connected for aligned objects. So we have aligned objects here. The objects are, here's your eye, here's the length of the rocket in your stationary frame, so it's in a line, it's aligned, and then you're also looking at a rocket in space moving at 0.995 c. So everything appears in a line. The eye, the original length of the rocket, and the new length of the rocket is moving at 0.995 c. So we're looking at a field of physics that explains how space is connected for aligned objects traveling at steady speeds v relative to the speed of light c. Well, we have that. We marked it off. It's 0.995 c. Where 1, all laws of physics are the same in all reference frames. So you have the stationary frame. All the laws of physics are the same in the stationary frame. If you're standing here in the moving frame on the moving rocket, all the laws of physics apply equally on the moving rocket. The second criteria is that all reference frames measure the same speed c. If you're in the stationary frame, you would measure the speed of light as speed c. If you were in the moving frame, you would also measure the speed of light as speed c. So special relativity is a field of physics that explains how space and time are connected for aligned objects traveling at steady speeds v relative to the speed of light c, where one, all the laws of physics are the same in all reference frames, in this case we have two, and all reference frames measure the same speed c.